So yesterday we learned about arithmetic sequences and series, which are a sequence or series that is increased, added, the same numbers being added each time. Today we're looking at a geometric sequence and series. And a geometric sequence is a set of numbers where every term after the first is being multiplied by the previous by a constant. This is called the constant ratio, and the constant ratio is r. So for arithmetic, we had the constant or the constant difference, which is d. For geometric, because we're multiplying, it's a ratio called r. But it's the same idea. The previous term is being multiplied by the same number each time for you to get the next term. So example 1, all we want to do is tell whether the sequence is geometric or not. So looking at part A, 81 to 27, how would I get that? Divide by 3, which is the same as multiplying by?
3.
No. 1/3, right? Dividing by 3 is the same as multiplying by 1/3. What about from 27 to 9? Am I multiplying by 1/3 there? What about 9 to 3? 1/3. And 3 to 1 times 1/3. So is A geometric? Yes, it is. Okay. So check B and C for me. Are they geometric? Part B. What am I multiplying by to get from 1 to 2? Times 2. What about from 2 to 6? Times 3. 6 to 24? Times 4. So is this one geometric? No. So not geometric. What about part C? I'm multiplying by what to get from -4 to +8? -2. What about from +8 to -16? -2. How about from -16 to 32? -2. And +32 to -64? -2. Multiplying, right? So is this one geometric? Yes. Okay. Make sense so far?
Yes.
Okay. So we also have a formula for finding a geometric sequence. Same types of terms and same idea as arithmetic, but the formula does look a little bit different. We use capital letters for geometric so that you can differentiate. So arithmetic use lowercase letters. For geometric use uppercase. So a sub n, the number term, is equal to a sub 1. A sub 1 is the first term. Times r. R is the ratio, the constant ratio, to the power of n minus 1. So for your general terms, when I just asked for what's the rule for the nth term, you're going to have to the power of n minus 1. You're not going to be able to do anything with that until you plug in an n. Okay? So this is your formula for a geometric sequence. So, for example, the sequence 3, 12, 48, that should be a comma right there, dot, dot, dot. What am I multiplying by each time? 3 times 4 gives me 12, and 12 times 4 gives me 48. So my r is 4. What is so I'm going to plug it into this formula. So a sub n equals a sub 1, the first term. What's the first term? 3. So we just plug 3 in here. Times r, the ratio, which is 4, raised to the power of n minus 1. And that would be your answer. That's it. We cannot multiply these two because are they common or like terms? They're not like terms because they don't have the same exponent. Okay? You are not able to multiply them until you actually plug in a number for n. So you just leave it like this. Not too bad, right? A lot less simplifying. So let's look at example 2. Write a rule for the nth term of the sequence, and then I want you guys to find a sub 7. Okay. Oh, that should be capital. Anyway. 3, 15, 75, 375. What is the constant ratio there? We're multiplying by 5 each time. Okay, so let's plug it in. A sub n equals, the a sub 1 term is what? 3 times r, which is 5, to the power of n minus 1. That's it. I can't simplify it anymore. But you need to find a sub 7. So a sub 7 equals 3 times 5 to the 7 minus 1. So a sub 7 is 3 times 5 to the 6th. And now we can simplify this all of the way. What is 5 to the 6th power? It's a really big number. Okay, so that is 3 times 1,000 or 15,625. And then 3 times that gives me 46875. So it's a really big number. So you guys are going to notice that geometric series, each term, it gets bigger and bigger and bigger each time, a lot faster than arithmetic, because multiplying changes the number more than just adding, correct? So each term is going to grow a lot faster than an arithmetic series. So will you guys do B for me? All right. So what color am I doing this one in? Okay. 152 to negative 76. What am I multiplying by? Negative, and it's getting smaller, so it's a fraction, so it's going to be negative 1/2. Negative 76 to positive 38 is also times negative 1/2, negative 1/2. Okay, so r is negative 1/2. So let's plug it in. My first term is, or a sub n equals, my first term, 152, times, in parentheses, negative 1/2 to the n minus 1. That's your a sub n rule. Okay, so let's find a sub 7. That is 152 times negative 1/2 to the 7 minus 1. So 152 times negative 1/2 to the 6th power. Which is 152 times, if I have a negative but it's raised to an even exponent, will my answer come out positive or negative?
Positive.
Positive. So times 1 over, what's 2 to the 6th? 64. Okay, so that's going to be 152 over 64, but that reduces. And it all reduces eventually down to 19 over 8. Or 2 point something. Okay? So you can leave it as a fraction. So this time we are given one term and r. So what do you guys think we're going to do? We're going to have to just plug in what we know. So negative 96 equals, do we know what a sub 1 is? So a sub 1 times, what's r? 2. To the n minus 1. If I have negative 96 as a sub n, what's n? 6. So to the n minus 1 would be 6 minus 1, which is 5. Are you guys okay with me just putting 5 instead of 6 minus 1?
Yeah.
Okay. Because the exponent is always going to be 6, or n minus 1. N is 6, so I'm just going to plug in 5. Is that okay?
Yeah.
Okay. Okay, so then let's simplify. Negative 96 equals a sub 1 times, what's 2 to the 5th? 32. So to solve for a sub 1, I'm going to divide by 32. So a sub 1 equals negative 3. Alright, so this is the piece of information that was missing. So I'm going to plug it in to the original formula. So a sub n equals negative 3 times r, which is 2, to the n minus 1. So that is your rule for the nth term. So find a sub 7 for me really quick. Okay, so a sub 7 would be negative 3 times 2 to the 7 minus 1. I'm actually writing that step this time, which is a sub 7 equals negative 3 times 2 to the 6. Negative 3 times 2 to the 6 is 64. So a sub 7 equals negative 3 times 64? Negative 192. Okay, good? Okay, what about part D? Part D is just like those previous problems where I've only given you 2 of the terms. I don't give you r, I don't give you the first term. So we're going to have to make 2 equations here. Okay, so let's do a sub 2 first. That's negative 12 equals, we don't know what a sub 1 is, times r to the n minus 1. If I'm using negative 12, what's n? N is 2. What's 2 minus 1? 1. Okay, so this is my first equation. Or actually, let me write the 2 minus 1 part. So negative 12 equals a1 times r to the first. So let's write a second equation using this guy. So this is negative 3 equals a sub 1 times r to the 4 minus 1, which is negative 3 equals a sub 1 times r to the third. Okay, so I have 2 equations. What I'm going to do is I'm going to stack them on top of each other. And negative 3 equals a sub 1 times r to the third. This is both multiplication. Can I use elimination here? I can't. I have to use substitution. So what we're going to do is we're going to use one of these equations, and we're either going to solve for a sub 1 or we're going to solve for r. Let's solve for a sub 1 because there's no exponents in it, right? Okay, so why don't we use this first one? To solve for a sub 1, what do I have to do? I can't subtract r because it's being multiplied.
Divide.
I need to divide by r, so it is negative 12 over r, right? Is everybody okay with that? I divided both sides by r to solve for a sub 1. Now I can take this guy and plug it in here. So that is negative 3 equals negative 12 over r times r to the third. Okay, what happens? The r's cancel a little bit. This r cancels and makes this one an r to the second. So we have negative 3 equals negative 12 r squared. Divide both sides by negative 12. So r squared equals positive 1/4. And then how do I solve for r? Square root. So r equals positive 1 over 2. Okay. So that's r. I still need to know what A1 is. So how am I going to solve for A1? Plug it in. Why don't we plug this back in over here because it's already solved for. So A1 equals negative 12 over 1/2. Dividing by a fraction, let's rewrite it. You okay? Okay. So this is negative 12 divided by 1/2. Is everybody okay with that? Okay, so this is the same as negative 12 times, dividing by a fraction is the same as multiplying by the, what? Reciprocal. So negative 12 times 2, which gives me A1 equals negative 24. So when I plug both of these things back into the original formula, I get A sub n equals negative 24 times r, which is, 1/2, to the n minus 1. Okay, so negative 24 times 1/2 to the n minus 1. Let me use a different color. I have A sub 3, which is equal to negative 48, and I have A sub 6, which is equal to 3072. So let's plug what we know and make two equations, okay? So this is negative 48 equals A1 times r to the what power? To the second power. And I'm writing small so that we can fit it. Okay, then we also have 3072 equals A1 times r to the what power? Fifth power. 6 minus 1 gives me the fifth power. Okay, so I have two equations. I can't use elimination, I have to use substitution. So let's solve for A sub 1 here. How am I going to solve for A sub 1? I need to get rid of that times r squared. So what do I have to do? Divide by r squared. So divide both sides by r squared. So that gives me negative 48 over r squared equals A sub 1. You can, it can be A sub 1 equals. It doesn't matter. Because we want to get rid of r squared so that we can solve for A sub 1. So now I have A sub 1. I'm going to take that and plug it in here to the second equation. Okay? So 3072 equals, let me separate this. A sub 1, which we solved as negative 48 over r squared times r to the fifth. I can cancel out two of the r's, so that becomes r to the what? To r to the third. Good. So this is 3072 equals negative 48 r to the third. I want to solve for r, so what do I have to do? Divide by negative 48. Don't worry, I did the math for you already. So r to the third equals negative, hold on, negative 64. Have I solved for r yet?
No.
No, I need to take what? Not the square root, cube root. Okay, so the cube root of r to the third is r. What's the cube root of negative 64? Negative 4. So r equals negative 4. Circle it so you don't lose it. Okay? So I have r. Is everybody okay with how we found r?
Yes.
Better? Feel better about it? Okay. How will I find A1? Plug it back in over here. Okay? So A sub 1 equals negative 48 over negative 4 squared. So that gives me negative 48 over positive 16. So a sub 1 equals 3. Okay? Negative 3. From R. We plugged it back in over here. Negative 3. Okay, so let's plug it in. Okay, so plug all the information back into the original formula. A sub n equals negative 3 times negative 4 to the n minus 1. And that's your answer. We will not find, I'm not going to make you find a sub 7 for that one.
Thank you.
Okay? Negative 4 to the n minus 1. The last thing we have to go over is a geometric series. Now, how does a series differ from a sequence, guys? A series, well, it's a series. It's not a sequence. A sequence is a list of numbers. A series means that we're doing what to that list of numbers? Adding them all together. So geometric series, the official definition, the expression formed by adding the terms of a geometric sequence is called a geometric series. So you're just taking a geometric sequence and now you're adding all the terms together. So we have a sum for that too. And the sum of a geometric sequence, S sub n, S stands for the sum, n is the number of terms, equals a sub 1, and that should have been a capital, but that's okay, times 1 minus r sub n, or not r to the n, sorry, a sub 1 times 1 minus r to the n, all of it over 1 minus r. This is really nice because when we take the sum, all of the information is going to be given to us. So look at example 3. I want to find the sum of the series from 1 to 8, so we're adding the first 8 terms of the geometric, and they tell us it's geometric, 6 times negative 2 to the I minus 1. What is a sub 1? Here's my formula for a geometric sequence. So what's a sub 1? 6. It's given to you. What is r? Negative 2. So the really nice thing about geometric sequences and series is that when you plug the information in, you can't simplify. Remember how arithmetic we had to distribute and then combine like terms? We can't simplify this, so everything is just out there given for you. Okay, so all the information is already there for you. So do we have enough information to plug into this? We do. The sum of the first 8 terms is equal to a sub 1, which is 6, times 1 minus r, which is negative 2, so put it in parentheses, to the n. What is n? 8. All over 1 minus r, which is negative 2. So let's simplify this. 6 times 1 minus, what is negative 2 to the 8th? Positive 256. 256. Over, if I have 1 minus negative 2, what happens there? It all becomes positive, so it's all over 3. So this becomes 6 times 1 minus 256 is negative 255 over 3. And before I multiply and then have to divide, do you guys see something I can do? I can reduce the 3 and the 6. 3 goes into 3 once, 3 goes into 6 twice. So my sum is going to be negative 2 times 5 gives me 10. Carry the 1, that's 11 for 100 or 510. Negative 510. So much easier than arithmetic, right? A lot less work.